Hello folks, here's another round of a chemical demonstration by Todd Burton. Today we've got silver nitrate plus copper demo. We're going to be adding some silver nitrate into copper and seeing what happens and recording the physical and chemical properties and the physical and chemical changes. So get ready with your sheet and get ready to fill this out. So first we're going to take copper, we're going to add it to silver nitrate. It's going to react and form silver plus cupric nitrate. We're going to see how that works. So when we come over here, we've got a test tube set up, clean test tube, and we've got some silver nitrate solution. Silver nitrate solution is made by dissolving silver into nitric acid. It's fairly toxic. We're going to be adding some of this here. Let me see if I can do this with holding the phone and doing it at the same time. You notice that it is a clear liquid. Looks like water, but it's not. It's definitely not water. Do not try this at home with this chemical, please. I am a trained professional. And we also have some copper wire. Copper, you notice is malleable. I bent it around this plastic stirring rod. So before we do this demo, let's talk about the physical properties of silver nitrate and copper. You can go ahead and fill this in on your sheet. So before we start here, physical properties of silver nitrate is that it's clear, it is in the liquid state. Copper has this beautiful reddish orange color to it. It is in the solid state. It's ductile, we can bend it, stretch it. Malleable, we could hammer it into a sheet. There's other physical properties, but that's just a few. Chemical properties before. We have silver nitrate, which is poisonous. It reacts with copper and other metals as well, but copper works the best, works very well with it. And copper reacts with silver nitrate. Could also put a chemical property up here that copper doesn't react with skin very well. That's why we use it on pennies and other coins. Okay, to the demonstration now. As we put this in, you want to write down any observations in your observation sheet that you may have. Just stick it down in here. Okay, now that beautiful copper color, that red color, is now disappearing. A few bubbles are being given off even. I think that's just some air escaping, but you can literally see the crystals of silver starting to grow. What is happening is the silver is being that is in the solution. It's clear. You can't see the silver is being replaced by the copper. So the copper is being eaten away by the solution, is going into the water. Now you can barely start to see it. The water is starting to turn just a little bit blue. That is the cupric nitrate in the solution. It is now aqueous. It has turned from copper solid into a aqueous cupric nitrate solution. And the silver that was clear, the silver nitrate, is now coming out of the solution and forming beautiful little copper or silver crystals on the wire. I'm going to knock this off just a little bit, and you can see that pure silver come out of the solution. And it'll redo it again. It'll start to grow just a little bit. It'll just keep doing this. It'll just keep growing silver until all of the silver ions in the solution, in the silver nitrate, have come out of the solution and been replaced with cupric copper nitrate, or we call it cupric nitrate. It's really just copper. Copper turns this water blue, very, very much the same reason why the Statue of Liberty is green and blue. When it is oxidizing with it's actually an oxidation reaction, and it's causing it to turn blue. Now we can knock it off again here. Now you can start to see that pretty blue color start to shine through there. If we actually look at a little bit of silver that was done earlier, we notice that it's very silver color. Got a little bit of impurities in it. It's very soft. That's pure silver. Doesn't weigh very much. Silver's in this powder form is not very heavy. We'd have to melt this and turn it into real silver, or turn it into a silver that we're used to that's in a hard state. This is just powder. And we come over here one more time. Again, it's still growing. Still growing silver. I always get the question, Mr. Burton, is this worth a lot? Well, not really. Maybe a few bucks, but this silver is pretty fine, pretty powdery. Not worth a whole bunch. And if we kept doing this over and over and over again with more and more solution, eventually this copper would disappear. It would run out, turn into nothing, just end up as blue cupric nitrate solution. So let's go back to the board now. So what we just saw happening was this. We took copper solid. Sometimes we represent solid as just an S. We added to silver nitrate, which was aqueous. And it reacts to form silver solid, which is that white powder, or that silver colored powder, and cupric nitrate, which is again aqueous, and that is blue colored. So in your box afterward on the physical properties, it's gone from being clear liquid state down to a soft silver solid. And the copper has gone from a reddish solid state that's ductile and malleable down to the liquid state, which is blue, and you can't see it anymore. Chemical properties. Silver nitrate that was poisonous and reacts with copper is now less reactive and a silver metal. That's why we use it on rings and jewelry, because silver is pretty non-reactive. And the copper has gone, it used to react with silver, has now gone, it's more reactive, and it's a copper solution. So copper that was unreactive has now become more reactive in solution. And we'll go over here one last time to see if it's still going. And sure enough, it's still forming silver. And we can pull that silver out even and take a look at it. pure silver on that copper. Back in and hit it off again. Make some more. And that is the reaction of silver nitrate plus copper. I hope you enjoyed. Please fill out your worksheet and go on to the next demonstration. Thank you. Bye.